All right, welcome everyone. I'm Paul Lefevre, the Xojo Developer Evangelist, and you are attending one of our weekly webinars. This week's topic is working with threads, which has proved to be a very popular topic. Lots of attendees today, so thank you any new folks that haven't attended one of these webinars before. So we got a fair amount of stuff to cover, so I'm just going to plow through things. And the way this works is you should see in your control panel for a GoToWebinar a little question window, and you can type questions in there, and they'll pop up on my secondary screen. You can type questions anytime you want. I'll pop over and read them and answer them when it seems appropriate. So don't hesitate to ask questions. I don't want to just wait till the end to answer questions. Although if we finish early, I'm always open to taking questions at the end. So today we're going to talk about threads. I actually put together a little mini slideshow for this. I don't usually have slideshows, but I do need to do a little intro talking, so I put together some slides. So before we jump into any code or look at any threading stuff, I just wanted to go over quickly what is threading. And threading is just a chunk of code that you're running outside of your main code, typically in the background. In Xojo, it's pretty easy to use. We'll talk about that in a moment. But the question is, why use threading? And the most common reason to use threading is to keep your user interface responsive during some long-running process, whatever it might be. Loading data from a file, calculating something, who knows? It depends on what your app design is. But typically, you want to move a long-running process off into a thread so that your user interface remains responsive while something else is being done. Now, a little bit about Xojo's threads. Xojo uses cooperative threads. This simplifies something called context switches, and I don't want to get too deep into how threading works, and my computer science background may fail me since it's been a while, but generally speaking, you have threads that are running, so you get all these little tasks that are doing things, and the CPU is switching between them, or the operating system more likely. And each time something switches from one thread to another thread, that's called a context switch. Cooperative threading allows these switches to happen at predefined endpoints. And in the case of Xojo, these are typically at loop boundaries, such as while loop boundaries where it says when or for next loop or something like that. You can also initiate a switch manually by calling various methods such as yield or sleep or stuff like that. But because these are cooperative threads, they can only use a single CPU core. So by using threads with Xojo, you're not going to get access to all 8 cores of your shiny new Mac, or however many cores these shiny new Mac Pros that theoretically are going to come out this month may have, or anything. It's always just going to use a single core of your multi-core CPU. Xojo threads have other things that we'll look at how some of these work, but they have priorities. So if you have multiple threads running, you can tell certain threads to get essentially more time to run than other threads. And that allows those threads to essentially get their jobs done quicker. And by default, everything kind of gets the same priority, but you can tweak and adjust those depending on what your apps need. And of course, threads can be suspended, and then you can resume them, and you can also kill threads, which completely terminates them and ends them. So let's jump into a little bit of code here, our threading example. So we can see an overview of the Xojo threads. So this here is the threading example, which just demonstrates some counting, and it's going to use 4 threads. This example is included with Xojo, and you will find it here in the threading folder, I believe. Thread counter, I think that's the one. All right, so I'm just going to run this so you can see what it does. So you can see it here on the screen, and you can see there's 4 areas, and each of these is its own thread. And it's pretty much just showing you information about the thread. It's showing its priority, and you can see these are just numbers. It tells you the status, and they're all currently running. And all the thread is doing, when we actually look at the thread code itself, is just counting. Nothing terribly exciting, but this is demonstrating the various ways that this work. So you can see the higher the priority, that essentially means the more times the more time the thread is given to run. So you can see by looking at these, the threads with the highest priority have a higher count. So this one has the highest priority, and this one's count is the highest. And this one has the lowest, and its count is the lowest. And you can make these things very low, so they hardly run at all, which may be makes sense if it's something that just needs to pull something very infrequently. Or if you just have a bunch of threads going and you really need one to get, most of the CPU time. So you can see that, it continues to update here as it's counting away. I can stop one of them by hitting the suspend button, and now you'll see it no longer counts because it is suspended. And I can start it back up by resuming it. And you'll notice when I did that, the status indicated that. And I can, of course, kill a thread, and its status changes to not running. Now, generally speaking, killing a thread is a little bit extreme. Odds are it's usually a better design for your threads to have a way to just naturally end. But kill is always available. Let's see. Now we can change one of the priorities here. I can drop this down quite a bit lower. And is that one not? Oh, I killed it. I can't change the priority of one I killed now, can I? Let's change the priority of one I haven't killed yet. And that might be a little hard to tell, but that one's now starting to count more slowly because it's getting far fewer, essentially time slices is the term that's often used, but little blocks of time, it's getting fewer of those, so it's going to count less frequently. So that's how this app works. So let's take a look at some of the code under the hood here. I'm seeing a question that's asking if audio's gone. Is the audio okay for everybody? I'll try yelling louder. All right. Great. So where was I? There was one question before that. All right, it looks like the audio is good. I got like 100 replies there, so that's good. Brief glitch. Yeah, I think I heard my time machine drive spin up. You know what happens when that happens, computer pauses for a split second. Let's see, I had a question before that though. Can you use threads to run a progress bar? Absolutely. We'll look at that example in a moment. So a thread in Xojo is just a class. And you can just drag a thread class right from the library onto a window if you wanted to. It's right down here, and that would give you a little object on your window that you can add something to. And threads essentially just have a single event handler that you implement, the run event handler. This particular thread is not on the window; it's actually a subclass that I've added to the project, but the setup's pretty much the same. And you can see this particular run event doesn't really do much except count. And it has not much other code in here. And I don't even think this line of code is actually necessary. It's going to yield when it gets to the loop boundary anyway. The container is just a little container that has the controls for displaying and managing the thread that is running. The window just has 4 of these containers plopped on the screen and then starts up all the threads within them. So you can see when you look at the container here, we'll go back. Priority is just a property, and the suspend and kills are just methods. So suspend and resume is just methods. And the next thing we're going to start talking about is updating user interface with thread information. And you'll see we have a timer on here that's doing that, and that's one of the techniques, but we'll look at that in a different project. But this project is a great one to look at to get a feel for how you might tweak your threads while they're running. But the act of implementing a thread doesn't get much easier than just dragging a thread class into the navigator onto your window and then writing code inside the run event to actually do something, which could be loading your file or doing the calculation or whatever makes sense. All right, so we covered these things here. The next thing to talk about is accessing the user interface from a thread. That's probably going to be a fair amount of our discussion now. But the big thing is threads cannot access the user interface. And this is effective for all operating system platforms, starting with Xojo 2013 Release 3. You'll notice I got a little star next to all OS platforms. There are a couple caveats there. The first is that Carbon is not affected by this change. Carbon is deprecated, so we're not really monkeying with it. So it doesn't raise an exception if you access the user interface from a thread in a Carbon app. Doesn't necessarily mean you should be doing that, but it doesn't raise an exception. Also, web apps are not affected by this. Web apps don't use an OS native user interface framework, so they don't have these restrictions that we're talking about here. But Windows, Linux, and OS X Cocoa apps, you are not allowed to access the user interface from within a thread. And what does no access mean? It means you can't read a property, you can't write a property, you can't call a method, you can't really call the events, but you just don't have access to anything that's on a user interface. Now, I don't have a bullet point for it, but that means the built-in stuff. So if you've added your own property to a user interface item like a window, you can access the property you've added, but you can't access any of the built-in properties that are on these controls. So you wouldn't be able to change the window title, for example, or in the case of a progress bar, you can't change the progress bar's value because that's built into the user interface element, and it can't be manipulated, accessed from a thread. Now you can write code that will do that. It'll compile, but when you run it, you're going to get this thread accessing UI exception at the line of code that accesses the user interface from within the thread. So we're going to take a look at a few ways that you can update your user interface with thread information without causing the exception. So we'll start with this example here. And this just has a thread that's just dragged right onto the window. And the run event here, again, is just doing a simple count. And I've declared a counter variable, just counting up to 100. And then here I'm saying, all right, I'm just going to update the progress's value. Now this isn't going to work anymore. So if we run it, you'll see it'll compile just fine and run. But when I hit start button, immediately thrown back to the debugger, and I have a thread accessing UI exception. This is a no-no. Can't do this. So now you see, and then this looks like fairly obvious code. Well, the compiler let me write it. Why can't I write it? And well, you can write it. It's just at a lower level, it's just not permitted. Then the user interface frameworks of all the platforms we run on are not thread safe. They don't support this sort of thing. And realistically, the fact that it worked in the past on some of the platforms was kind of a happy accident to a variety of things that as the frameworks have needed to be cleaned up for the new operating system or whatnot, is just not something that can be sustained any longer. But the quote I found on the internet regarding that is, other frameworks don't have this ability either. And you end up with, if you do somehow finagle things and you try and trick it so this works, you end up with apps that don't quite work reliably for reasons that are not at all clear. And no one ever wants to have apps that fit under that situation. So how do you update the user interface from within a thread? Well, the flip side is pretty easy, and changing this code is not terribly hard to do it. The trick is to remember that the user interface is updated by one thing, and that's the main thread. The operating system controls that. The main thread of the operating system is what is responsible for updating the user interface. So all your little threads can be running and doing their own thing. They can't directly update the user interface because only the main thread can do that. But the main thread can ask the threads for information. And then the main thread can use that information to update the user interface itself. So essentially, you do the reverse of what is described here. Rather than having the thread update the user interface, you essentially have the user interface ask the thread for the information, and then the user interface update the thread. Update the user interface, update itself, essentially. So how would we change this example from UI thread bad to UI thread that works? Well, if we want to have something on the main thread that can update the user interface, the best thing to do is to have a timer. A timer is a little control that runs periodically, runs in the main thread, and its job can be to simply periodically poll or ask the thread, what's the current value, and get it, and then it can update the progress bar for us. So let's add a timer here. Actually, I wanted to show the layout first. Timer. So I have a thread timer here. I'll add its event handler. And the timer just needs to get a value. Now, actually, what we can do on the thread is right now it has a little internal value, a local variable that's containing the count. But we, like I had mentioned earlier, we can put add our own properties to the window. They're not going to be part of the UI stuff that we can't access since they're just regular properties. As long as, of course, what we've added doesn't then inadvertently touch the user interface like a method or something like that. But we could make a property on the window and then use that as the counter. And then we can just swap that out here. So now, rather than counting my local variable, I'm counting up using a property on the window. Now we can have the timer check this property periodically. I guess I can leave that up. So we can just have and of course I do need to get rid of this line. So now rather than the thread doing anything with the user interface, commented out the line that touches the user interface, the thread is just counting. It's just doing its one task, which is counting. The user interface, the window, is just doing its thing, which is running a timer, we can just check here. This is running 1 a second, and we can drop that down to be a little faster. And this is just doing its thing by saying, hey, thread, how far along are you? Now, if I haven't made any mistakes, which I always tend to do when I live code, there's one mistake. You can see that this works more typically. The timer is now running in the background. It's getting the thread progress, and it's updating the progress bar accordingly. All pretty easy and straightforward. And it's not too hard to make this flip, but it does require a little bit of a mind shift because you're now separating your processing a little bit. Your thread is now focused on only doing whatever it was it needed to do, and the user interface is focused on only user interface stuff. So this is one technique that you can use to do this, or to upgrade your threading code so that it still can provide UI updates. Now this, although relatively simple technique, can get a little trickier with more complicated stuff. So what one of our engineers has put together is another example. And this is also included here. Here it is, UI threading with task. So to try and simplify this, we've created a thread subclass here in this task folder. It has two parts, a thread subclass, which is called task, and then just another class that helps, that it's used to help manage things. And essentially what this subclass does is provide you with two event handlers. You can see here on the window. You still get your run event handler like you had before, but you also get a new update UI event handler that runs in the main thread. And because it's running in the main thread, you can update the user interface from it. All right, before I get too far along here, I got, let's see, one question here. Does this technique work for Carbon as well as Cocoa and OS? Yes, absolutely. The timer technique works everywhere. So yeah, if you have ARPs that are still in Carbon that you're thinking, all right, I'm gonna need to move these to Cocoa, you can absolutely make the change using either of these techniques, the timer technique or this technique here that I'm about to show you on the Carbon side, and then they'll just translate over to the other platforms. So yeah. So like I was saying, the update UI event handler runs in the main thread. This means you can update the user interface. So essentially, by using this subclass and using this in place of thread on your Windows, you can almost keep your code exactly the same. But instead of having the line of code right in the run event handler that updates the user interface, because that's not permitted because it's running in its own thread, you call the update UI event method with the information that's needed to update the user interface. So in this particular case, you can see we have the same code here. It's just looping through and counting. I'm calling the update UI method, and I'm telling it that the UI, essentially this is using a pair, and I'm just saying the UI progress has this value. You can also pass in a dictionary, so you can pass in all kinds of information that you may be tracking on your as your thread's running. And you pass that in. So by calling this method, it eventually triggers the update UI event handler running on the main thread. And then in here, you can look for a particular value and update the user interface accordingly. So this particular thing is checking the dictionary of arguments to see if it has one that's called this value. And if it is, it gets the actual value, converts back to an integer, and uses it to update the progress bar that's on the window. So here you don't have to worry about throwing a timer on your window or any other shenanigans, essentially, to get this to work in the appropriate order. You just essentially replace your current thread with the task subclass, move all your UI update code into the update UI event handler, and then in your run event, pass in any information that's needed to update the user interface. Using this particular thing is probably even easier for people that have any threading code that is directly updating the user interface. You can just essentially drag this folder or copy this folder into your existing project, change your supers, implement the extra event, pass in the things, and you're done. And it probably wouldn't really take that long. So you can see running this one. It works the same as before and the same as the timer method. It's just a different implementation that might be easier for some of your projects to adapt. And let's see, I got a question here from Oblio. Is this included with Xojo? And yes, it is. It's in the same folder as before. One of these folders anyway. It's one in the desktop folders. There's probably a threading or a UI threading folder in here, depending on the version you're using. And there's going to be one of the examples in there. I think this is what they were called in older versions, and current versions should have it called like this: UI threading with task or UI threading with timer. But anyway, those are all included, so you can just grab the code right from your Xojo examples and test it out with your own projects to see how you would update them. All right, I got one more question before I progress. I got a question here from Anthony. It says, which of these methods is the recommended way to do it? Well, I don't know that either is recommended. Both are perfectly valid, and I'd say are equally valid. The timer method is nice because it's pretty simple and it's easy to understand. And if that meets your needs, it might make sense to go with that. The task method is nice because it's really easy to implement. But if you dig into the details of the task class, you'll see it's a bit more complicated to understand. I'm not even going to attempt to explain it here. But there's all kinds of code that's in here to essentially ensure that those events get pushed off into the main thread. And it is using a timer behind the scenes and a few other things. So if you're okay with just kind of dropping this in there and not necessarily having to dig around and figure out how it's working, this is probably using the task is probably the easier way to go to update your apps than attempting to create a bunch of timers and linking them up to your threads. But we offer both techniques so that people understand what's going on and why you want to do these things. So accessing the UI, that's a big thing, and it's we've had a fair amount of people on the forums that express confusion. They're a little upset because of this change, and understandably so. And I'll talk about more of that at the end. I do have some other questions that were submitted ahead of the webinar from people that couldn't make it, and we'll cover those. So I mentioned earlier that threads can't use multiple CPU cores. And that's too bad because computers these days often come with multiple CPU cores. I don't actually know if you can even buy one today that just has a single core. Certainly you can set up VMs that use just a single core, but I think even my iPhone has 2 cores in it now. So sometimes it's handy to take advantage of the multiple cores and have your things happen faster. And happening faster reminds me of a point I did want to bring up regarding the use of threads. Because all the threads are running on a single core, the use of threads is not going to make your app run faster. It's more than likely going to slow down your app because you're essentially adding some overhead. But the benefit is that your user interface will remain responsive, and that almost always gives the end user the perception of things happening quicker. So as an example, well, actually, probably, I think the example we'll look at related here to the multiple cores might demonstrate this. But if you had a really long-running process that was doing a lot of calculations and whatnot and ran in, say, I don't know, say a minute, and you just had it on a button that you clicked, and it did its calculation, it ran in a minute. You decided to move all that to threads, got it all working great, user interface was responsive now, it showed a nice progress bar and whatnot. You might find that instead of taking a minute, it now takes a minute and 5 seconds. Made up numbers, but there is a little bit of overhead there, and it can cause things to happen more slowly, which is why, depending on what you're doing, tweaking the priorities and other things can help mitigate that so it works better. So multiple cores. The use of multiple cores is not something that threads can do. So if you want to do that with Xojo, you need to use separate processes. And in the case of Xojo, the way to do that is with a helper app, which typically you're probably going to want to be a console app, but it doesn't have to be a console app. And how that works is you have a main app that probably has your user interface, does its things. And then the helper apps are launched by the main app. And as each helper app is launched, it gets its own memory space. And if you have available CPUs, the operating system is going to assign it to a CPU, so it will get its own full CPU to do whatever it needs to do. But because these things are completely separate and distinct, you have to come up with a way to communicate between the main app and the helper app. And there are a variety of ways to do that. The simplest, which is what this example is going to show, is that it uses a console app that just returns a result when it is finished. So essentially, the communication from the main app to the helper is it supplies the name of a file to process, and then the helper app, after it has processed the file, returns a result back to the console, essentially. You could use files to manipulate things. You could use IPC, inter-process communication, to send data back and forth. But the benefit of this is that everything is completely isolated, and you don't have to worry about dealing with synchronization via mutex or semaphores or anything like that. You don't have to worry about running out of available memory because it's all split out appropriately. But it is more overhead to manage this because Xojo, as of currently, does not provide any IDE assistance with creating these helper apps. You do have to create them all separately and do whatnot. And whatnot means we'll take a look at an example so we can see what that looks like. All right, I want the word counter. So this word counter example consists of two projects. The word counter project is just a console app that gets in as a parameter to the console app the path of a file, a text file, and in the text file it's going to count the words. And it does that using a class that's just called word counter. That if you dig into this class, you will see that the word counting method is horribly inefficient. But that's okay. That's kind of intentional so that this actually counts slowly enough so we can see the benefit of using multiple cores. If we actually used a nice slick word counting method, it would be so fast that using multiple cores would be silly. But this is a nice, essentially slow thing that we can try out. The word counter GUI app lets you add files to the list, and then it lets you count the words in all the files in 3 different ways, so you can see the difference. The first way is it'll just count them one after another. No threads involved or anything like that. The UI will be essentially frozen up. And it'll just count a file, grab a file, count the words, display the word count. The threaded method will essentially spin off a thread for each file, count the words in it, and then just update with the word counts. And then the processes method will launch a helper app for each file that counts the words, and then display the results. And then each of them will show the elapsed time for how long they take. So let's run that and take a look. So I'll add a couple files here. These are just snippets of Edgar Rice Burroughs' Princess of Mars. So if I hit the count button here, you'll see that it's working, and I got the little busy bee here. On Windows, I think the title bar probably will change to not responding, as this thing is kind of just chugging away. All right, so as this is chugging away, all right, it's now done. So it took about 20 seconds to count 2 files, or 21 if we want to round up. All right, I think that clears it, so we'll run it in the thread. Now, when we do the process one thing to remember is that there is time associated with launching processes and getting them all set up. So for small numbers, it's entirely possible there won't be a huge time saving. So we'll see when we run that. So this took about 22 seconds, so a little slower, about a second and a half slower than just running it sequentially. And then if we switch to the process method, whoops, I hit the wrong button. Count words. And I didn't add all the files here, but one thing that's neat to see when you have a bunch of files here, when you're doing the threaded or the processing one, is that the counts appear in the order that they finished counting. So the smaller files get counted first, so you might see entries at the bottom that blip in with their word counts while longer files are still counted, whereas a sequential one just obviously does it one after another. So we can see here on the process one, it took about 12 seconds. So it did, it was taking 20 seconds doing it sequentially. We run this on 2 CPUs. Let's see if I can actually display the activity monitor. I guess that's the... All right. This doesn't really show the CPU separately, I guess. I have a different utility on my main computer that does. Oh, I got this little gadget here. How many we got here? 1, 2, 3, 4, 5, 6, 7, 8. I guess that's right. But you can see, we'll run this again so we can see how the bars move. But you can see that this didn't take half the amount of time. 20 seconds, half of that would be 10 because there is some overhead involved with starting things up or whatnot. But I mean, still 12 is better than 20. And this is sort of thing that scales. So if I launch that there, you can see the CPU bars are jumping up. Now my CPU does not actually have 8 cores. It's a quad core with hyperthreading. I'm not enough of a CPU guy to know exactly how that affects some of this stuff, but from what I understand, these extra cores aren't real cores, so but you can see now that it's done, it dropped back down. So that's how that technique works. Now this code is quite a bit more involved, particularly because it's doing 3 different things. But let me just scan the question list before I jump into any of that. Right here, there's a question here that says, is there a way to use multiple cores? Well, luckily we're talking about that. Is there a way to actually select the CPU for a thread helper app? Not at the moment, there's not a way, unless there's something on the system level that you could do when you're from terminal or something like that. But offhand, I'm not aware of a way. There's certainly no built-in way in Xojo to control that because you're just launching an app, essentially a console app, and that's all completely controlled at that point by the operating system as to how it's going to send it along to what CPU or whatnot. Let's see here. Do you need a special license to make console apps if you have a desktop license? Yes, if you just have a desktop license, you can only make desktop apps. You can't make console apps. You can make console apps with Xojo Pro license, which includes all of them, obviously, or you can get a separate console app license to do that, or you can create your helper apps as desktop apps, but kind of like what's called a headless desktop app that doesn't actually present a user interface. That probably would have a little bit more overhead because it's still going to have all that stuff to load up behind the scenes or whatnot, but that might be an alternative as well. All right, so let's look at some of the code here. Another question here, how you call a console app. So we're just going to look at how some of this code is working. So essentially, there's a couple classes here, and let's take a look at Well, word count shell is the new one. And as you can see here, this is just a class on here that's a subclass of the shell class. Because that's how I'm launching the console app, is by using a shell, a Xojo shell class, and I essentially point to the console app that's built and sitting on the disk next to the main app, and I send it a command. So here you can see in the simple count words method that this is what's calling the console app. And it doesn't do anything terribly sophisticated. It just has the name of what the app is here specified. And then it gets a folder item to point to it. And then it verifies that it exists. And if it does, it calls the execute method, which is part of the shell class, because this is a subclass. And it passes in the path of what it's executing, and then the file to actually process, to count the words in. And if you look here at the Finder setup, I can find my Finder window. You can see right here that I've built the word counter console app, and I just dragged it over here beside the project, at least on OS 10, so that when I run the project, whose debug app will appear right here, this is right next to it, so it gets found by these commands. A more sophisticated setup would probably require you to maybe have a preferences setting or something where the user can choose where the helper app is, or you put it in a specific location and then you just have a better path to it. But that's what works great here for the demo. And here's the question here. If you launch more helper apps than you have cores, what happens? That's a great question from Ken. Well, you generally are probably not going to want to do that because you're not going to get any benefits. Is essentially you're having the more processes than there are available cores, mean that a single core is going to have to run more than one process. And that means it's going to be splitting its time, and it's not at that point terribly different than threading at that point. So that's going to depend on your app design, of course, as to how many you want to spin up. This particular example is spinning up a process for each document that's added. So if I added 20 documents, it's going to spin off 20 apps. 20 processes. Well, I've only got 4 or 8 cores on this machine, depending on how you consider that. So that's not terribly efficient. I mean, realistically, I probably don't really want to spin up more than 3, maybe 4, because the UI app isn't really doing anything. So I could probably take over 4 CPUs to count the words. So you might want to, check how many CPUs are available. You might want to provide a setting for the user to tweak how many processes get started. It all depends on how you want to design that. But there's no real benefit to launching more processes than you have cores. I mean, it'll still work. Everything's going to run the same as, I have 2 user accounts open now with countless apps open. So I'm certainly running way more processes than I have CPU cores. And the operating system will have no trouble with that. But for maximum efficiency, you want to keep number of processes relatively close to the number of cores. Right. Well, I got one more question here. Is there a URL where you can download? Yeah, there is a URL. Again, this example should also be included in at least one of the newer Xojo installations in the advanced folder. I don't think it made it in this one I'm running. No, it's in the console folder. Yeah, the newer installations in the console folder will have a multiprocessing folder with that example, with this example. And there's also a blog post, and you want the URL. I guess it's here in the mouse down. So there you go. Go to our blog. And apparently the post is in July. Google search, I'm sure we'll find it if you just search Xojo blog and multi-core processor. But in July, there's a blog post I wrote that covers this. I'll leave that up for a second in case anyone needs to quickly type that into their browser. Um, so yeah, you definitely want to dive into this example a little bit more, and so you can compare the differences between running something sequentially threaded and on multiple processes. And this is broken out such that if I go back to the main class, yeah, the word counter class is what I was thinking of. This is the class that actually does the counting of the words with this inefficient method. And it's this same class that's used in all three of those techniques. So when you're counting it sequentially, it's still using this class to do the counting. When you're counting it in a thread, it is still eventually using this class to do the counting. It creates a new instance of it and it counts the words. And when it's counted in the processes, the console app essentially also has a copy of this class sitting in it that does the counting. So essentially, the actual code that's doing the work is always exactly the same. It's just how it's being used that differs. And that's just a general programming thing about the implementation detail about how these word counts need to occur from a optimization standpoint doesn't matter. Uh, it's how the word counting is one thing. We can use that same technique regardless of how we implement the efficiency method. So you can see an example of that, and you can play with this and take it apart and whatnot. All right, let's drive back here. All right. And some of the questions I want to just touch on that were asked ahead of time. And before I jump into those, I'm going to take a quick look at the live questions here. Let's see our examples on the Xojo wiki. Right now, the Xojo wiki has a link to all the examples that you can download. The specific examples are not individually called out on the wiki at this point. I will also remind people, though, that this stuff is covered in the user guide. There is a section here in book 3, sorry, the framework book, in the concurrency chapter on threading. There's examples of this, and there's also a section on the task class. And there is also information on using the task class example in the wiki. So I'm sorry, I did call that out in the wiki because it was important enough. So you can find that in the wiki. Just a question here about past webinars. Yes, this webinar is recorded, as are all of them, and they're available on the website and YouTube to watch later. Let's see, Ken has a question here. Can the helper app run on the Mac Mini and send the results to a GUI app running on a MacBook Pro? I don't see why not, as long as you've implemented the appropriate communication protocol. You could certainly launch something in that manner, but that does make the communication trickier. You can't probably just send files easily or get return values back. You're probably going to use some networking protocol to send the information that it needs to process over and then maybe get the results back. But yeah, that's definitely doable. Let's see, someone mentioned multi-thread. Some of the multi-thread projects are not in R3. Yeah, they might not have made it into R3, but and one thing I didn't mention at the beginning is we did release R 3.1 today, which is a very minor update, which fixed some packaging issues, particularly with some of the multilingual installers, and it did also make sure that the examples are up to date. So you might want to just head over to the Xojo site and grab 3.1, which should have all the updated examples for you. And someone else asking the webinar will be available on the German website. Well, I can point you to where they're always available. The website, as you can see here, the webinar section sometimes doesn't get updated quite as quickly, but the archives are usually on the bottom. But you can also go right to the wiki to get them. And since I do all the wiki updates, they often are updated a little quicker because I'm the one that generates this stuff. But if you go to the videos section, all the webinars that are recorded are here with links. And of course, you can subscribe to our YouTube channel. And then you're notified when I upload new videos. All right. So a question that was asked, I'm sorry I didn't write down the names of who asked them, but these are all sent to me via email. Are threads usable by beginners? And I think they are. Xojo threads are pretty easy. You just add the thread, you implement the run event handler, and uh, and then the two techniques I showed here are, once you do them, and it's certainly if you started with them, they're incredibly easy to update the UI. So yeah, I think the way we've implemented threads in Xojo make them very approachable by beginners. Another question is, well, why go through all this trouble? Why not just use a timer? Well, a timer um, runs on the main thread, and its purpose is to do something periodically, not to necessarily do something long running in the background. So you don't want to use a timer for that because it likely will just lock up the main thread and thus your user interface. If you have a timer running, once a second, and then in that second it's running a long running process that takes 5 minutes, that's not going to give you what you want. So you want a timer to run periodically, do something quickly, and then finish so that it can run periodically later. A question: is thread.kill safe? I don't see why not. Is it great design? Yeah, well, that depends on your apps and what you feel about design. I would probably say usually not. If you need to kill your threads that drastically, maybe you might want to reconsider your design and see if there's a better way to implement the threading so that they can just terminate nicely. But I don't see why thread.kill would cause a problem. I think I have seen maybe a bug in maybe it was release 2 where thread kill sometimes didn't work on Windows. And I suppose that some might say, well, it makes it unsafe. I don't know. If there is a bug, we'll likely get that fixed. But if thread.kill isn't killing for you, by all means, re-implement the thread so that it can just terminate itself gracefully. Let's see, will threads speed up my app? And I did address that, and the answer is no, not technically. They won't speed up your app. They'll more than likely slow it down. But that doesn't mean you should avoid them because most users will think your app is faster if when they click something, your thread goes off and does its thing in the background and they can go back to doing what they were doing in your app. Your app will feel much faster to them. So from a perception standpoint, it'll make your app feel faster, but it'll actually take longer for tasks to complete. And the last one, I made up this last one. Not being able to update the UI from a thread makes me sad. How can I cope? And yes, we do have a lot of people that this makes them very sad, and they fret about how they might be able to cope. And I'm hoping that the two techniques I showed you today do allow you a way to cope. And I will, still threading in Xojo is much easier than trying to do threading in just about any other tool set. It's not like other tool sets are going to let you update the UI from threads either. It's kind of an operating system restriction more than a framework thing. But certainly, if you're interested in the how and why this particular thing isn't possible, it's just generally a really difficult, hard problem to solve. If you go to Stack Overflow and search on that particular topic, update the UI from a thread, there's got to be 500 C# related questions about explaining how to use delegate injection to get into the event loop to update your user interface from a thread. Java had an equal number of, confusing to me at least, things on how to do the same thing. So best way to say is how to cope is, well, at least we have two relatively easy techniques that you can do to get your UIs updated with thread information. All right, let's see here. Got a couple more questions on the question list. Did 3.1 fix a page panel ID display bug? Well, I don't know what display bug that would be, but I can definitively answer no. 3.1 didn't fix any bugs other than installer related stuff. 3.2, which will probably be going to beta today, does have bug fixes in it. Specific ones I don't recall off the top of my head, but if you're on the beta program, keep a lookout later today I shall hopefully get the beta for that posted. Let's see here. Will threading be available for iOS 7 support? Someone always figures out a way to sneak in an iOS related question. Uh, Actually, I don't know if threading is going to be in the iOS stuff, so I can't answer that. I don't know. I should look into that, but I really do not know. All right, and let's see. Another question here. Do threads automatically die when it finishes processing all of its code? Yes. Once the run event handler finishes, your thread ends. And that's the way to end a thread safely. One technique is in your run event, because the run event's typically going to have a loop of some kind. If you're doing processing, you're looping. So your loop could have a condition that checks, oh, should I stop soon? And it's a Boolean or something, and you can set that on the thread itself. And then your little loop could check, oh, should I stop soon? All right, I should stop soon. I'm going to stop looping and just let itself end. And then that's the end of the thread. It's done. It's a nice, clean, safe way to stop your threads. And it depends on your design, but it certainly feels less aggressive than saying kill you thread. All right, so I think that's all I had on my little slide thing. Yep, no more pages here. And we're checking on time. Oh, look at that, right on time. All right, I want to remind people before I sign off, and I'll be doing this every week until March, well, week before March 26th anyway. XDC next year, March, Las Vegas, be there. Monte Carlo Resort, 3-day Xojo conference, lots of sessions. We're going through the list. We had a lot of our customers submit sessions. We're going to have a lot of new stuff this year. I think we've already starting to get registrations. These sort of things have been known to sell out. Stay on top. Dana tells me that we're going to be releasing the list of sessions and schedules within a month or so. Hopefully I'm not going to get in trouble for saying that, but they should be out soon. I know most people aren't going to sign up for a conference unless they know exactly what the content is. Can't say I blame you. So stay on top of this page and see what's coming up, because this is going to be the place to be. And plus, if I haven't met any or some of you, I'm sure I've met some of you, we'll get to hang out and chat, and that's always fun. And I've never been to Vegas, so I'm just excited to go down there. I'm in Maine, and it's starting to get cold up here, so anywhere it's warm is where I like to be. And I'm getting a reminder from a couple people about the poll, and I thank you, Jim and Marcus. I'm going to run that while I look at the next question. And this is the usual poll, but I'll just run it here quickly. And in case there's a question, legacy key just means that you have a license to Real Studio, I guess, but not to Xojo. And let's see, Horst, I think I'm pronouncing that right, asks if the helper app can be located into the resource folder of the main GUI app. I imagine it can. I don't see why not. As long as you have the ability to access it and run the app, that should be okay. It's possible, though, that depending on installation, you may not have those permissions. And it may be that you don't want to run it directly from the app in the case of an OS 10 app where it would be in the bundle. And you certainly, in that case, you want to, if you're creating temp files or you're writing files, you don't want to be writing any of that in any app folders whatsoever. And if your OS 10 apps are sandboxed, that's obviously not going to fly either. One technique I've seen people doing is maybe include the apps in some sort of resources or part of the installer, but then when the app is first launched, it moves them out to another location that is a little safer to run these things. But I think either technique will work. All right, let me see about this poll. I can close. Thank you, everybody. All right, well, looks like we're right on time. And I will just bring up what remind people here, I don't know if this was up last time, but I have the full webinar schedule up for the rest of the year. This goes right through, well, mostly to the end of the year. There's none for the last 2 weeks of December because of holidays and whatnot. Next week is the 15th, and that's the open Q&A webinar. So I'm just here to answer whatever questions people can dream up, and hopefully I'm not just dreaming up and making up answers, but by all means, check that out. And then coming up after that, I'm going to be covering some power user IDE tips, our monthly intro to Xojo thing, and then I'll be covering SQLite. And then the first, a 2-part webinar, and we're going to make a text editor. And right now, I haven't fully designed this out yet. It looks like I've got about a month to do so. But I think I want to make something that looks somewhat similar to like Text Wrangler or something like that. And then to close out the year, we'll show you how to localize your apps. And I think I'm going to cover desktop and web here as well. And then we'll talk about accessing third-party web services from your Xojo apps using SOAP and REST and stuff like that. So I want to thank everyone for attending this week's webinar. And be sure to tune in to future ones. Tell all your friends, and have a great rest of your day.